A big welcome and thank you to Google and specifically Alex for supporting us with this program. We're joined today in our audience by education providers, our Technical Education Advisory Board, NCFE colleagues, and IT departments from across our network, both internal and external. This is now our second session in the program that we've partnered with industry leaders from across the digital sector to bring you useful and informative content to support your own development and that of your students. My name is James Lane. I'm the Sector Manager for Digital here at NCFE. I'm going to cover briefly some of the housekeeping we've got to today. For questions we have with all of our sessions, the question box over on the right. You go ahead and ask any questions you have there, and we'll monitor that for them coming through. Of course, we'll do our best to cover everything today, but in the event that we're not able to, we'll be sure to follow up with you afterwards. And this can include specific questions about today's topic or something that relates to a separate session. Our additional sessions we're already planning, and we've sent you some details already on that. Machine learning is coming up. If you haven't had those already, if you speak to your account executive or contact me directly at jameslane@ncfe.org.uk. With that said, it's so exciting to bring this together, and I know I speak for everyone here when I say that I can't wait to see what you're going to share with us today. So let's get straight into it, and I'll pass you over to Alex to get started.
Okay, very good. Okay, here is it. Google Chrome, very good. From this window. Okay, so it should work. You all can see my screen?
We can, yes.
Okay, nice. So let's start. So it will be an introduction about robotics. I will show a few use cases we have here at Google, but also other industries as well. And I will also talk about career opportunities because I believe that's something that would interest students and people as well who may seek for a job. And this particular field is kind of one of the big fields that are taking more and more importance on the professional side. So little things about myself. So born and raised in France, obviously, you may already have heard that. So I studied electronics. That's also why I kind of explain, or at least discover with you a few point of view about robotics. I've also done 5 years of apprenticeship in IT and networks. So interestingly, I was able to study and at the same time to work for an actual company and understand the way companies collaborate and make things happen with people. I went also in HPC, computation at large scale on investment banking. Also worked at IBM, and now since 3 years and something, I'm working at Google Cloud as a customer engineer, which is a sales engineer about everything on cloud. So to enter into this topic, one first quick overview about what we may expect in the future. It's interesting because for a long time, and even when I was young, and it was not, I hope so at least, it was not so long ago, we were expecting more things like flying, like a car flying, having people going faster from one point to one other, etc. And finally, what we got is less about flying or getting faster, and more about getting things autonomous, doing things for ourselves, such as, okay, you receive a lot of mails, maybe we can make the management of your mails faster, or we can make sure that, okay, that's something about a delivery, that's something about billing, that's something about professional, and make things that that are autonomous and help people. And that's something we also seen a lot on the robotics, meaning that instead of going to something with an operator, someone who controls it and get full efficiency with that robot, we get more and more something autonomous that is able to make some decision and act on its environment. So that's really something that we can see. Then what we may call a robot and why it is different, or why may we perceive it as different from an actual computer. First thing is real-time processing, meaning that a computer, if you wait for an email, it may take a few seconds or minutes, even hours on some cases. It's not a big problem. With a robot, it can be a big deal, meaning that if it's traveling from a point A to a point B, or if it's doing something on its environment, a direct environment, you can't wait a few minutes. We can see that, for example, with robots we send in Mars. We can operate them from a long distance. But since there is this long distance, we need also some autonomous actions that doesn't need an operator to act. Because if we wait for the operator to be able to see something and send commands to the robot, we may lose what we sent. So that's really something, real-time processing, and that's really something that exists since a long time ago. We worked a lot, to get programs that are really fast and able to act in a few milliseconds or a few seconds in some cases, but always in a reaction about the environment and something that is real-time processing. You expect also new interfaces. What we call interfaces, it can be a few motors, a few actuators. It can be sensors. It's a lot of different devices that are able to interact and understand the environment. While with a computer, you get something like a screen, okay, a webcam, a keyboard, but nothing really different from one computer to another. While on robotics, it can be very different from this little, I don't remember how we call an aspirateur in English, but that's okay. You may have recognized it, the little device in the middle. While a robot with hands, like here it's a toy, but it can be definitely something interesting in a real world, such as in a warehouse, to move a box and things from one point to another. So as you can see, it's really different interfaces and they don't work the same way. Then we have a question, is it really operator free? It depends. We have this little drone at the right, is definitely operator free. We don't want someone always looking at the screen and then send commands to that drone. We want it as autonomous as it can be and able to deliver the package with no interaction on the operation side. Or very little, like, okay, there is an alarm, let me check what happened, but not all the time in front of a screen with a little command in the end to send the orders. And then what we expect on the robots is definitely to be adapted to what we need from it. You don't want a full-size robot to deliver something, or you don't want a full-size robot like human size or even bigger to move boxes. You want a robot that is able to move things around and is really efficient to do so. And the human figure, the human model, can be really good in some cases, but definitely not for all of them. We are really interesting as creature because we're really versatile. We're able to do things really different from one time to another. And for a robot to do the same, it would cost a lot and it will not be that efficient to do so. So really those things are key to understand the difference between robots and computers or regular hardware and circuitry. Then when we talk about it, we say, okay, robots are really something we can see a lot. We work with them since a long time. Having some autonomous system is really something regular. From I don't know, having a door that open and close itself, like when you go to a shop, or from something that is more sophisticated, such as the robots we send to Mars. It's not something new. We have them since tens of years. So then why we don't see them a lot more, like in our houses, in the streets, or anything else? So a few things that I believe it's really important to tell again. First, a robot can be really different, and while you can see on the right side of my screen, really something that looks like a full robot with a lot of capabilities, you can see that it's not that easy to use. Why I tell that? It's not because it's really complex and you need a specific operator. It's much more about when you look at the right robot, you can see that all moving parts are accessible during operation. So when he's trying to cook, I don't know if it's cook well, but definitely it will be able to cook something for us. Moving parts are accessible, meaning that if at some point the robot do something wrong, you may be hurt if you're near it or if you try to intervene during its operation. While on the left side, it's much more easier to get things like protected and accessible for people. Like, okay, if I try to open that bowl, you will see that any moving parts such as the blades, etc., will stop themselves. It's a security. It's not the computer who will decide to stop something. It's the simple act of opening it that will cut the power to the blade, or to cut the power to the head, the hot parts. So definitely something that are more easy to get safe and more easy to get accessible to people that are not that well trained to use them. We want to use a robot, we want to be able to use it without having a few years of study before being able to operate them for at least in our houses. You can see also something that is really important. It's the size. On the right side, if at some point you have a part that is not working as expected, you just can't open a box, put everything in the box, send it to the manufacturer, then they will check for it and make it work again. It's really more complex. You will have to have someone go to your house, to your kitchen, check for this, maybe bring materials, parts, etc. Hope they have everything needed to get it working again before having it maintained. So it's really difficult. And last thing, and I believe it's the obvious part, it's price. On the left side, it's really something like, okay, it's a moving blade. We have moving blades since a lot of time. It's a heating bowl, no problem. It's a long time ago. We have them. Okay, there is that screen. There are maybe a few things like programs to get things smarter, but definitely nothing that are too complex to integrate. While on the right side, it's really something new that needs to adapt to its environment, to what you asked from it, etc. And so definitely something that is pricey and that needs some more integration and some more preparation before being able to work where it should. So definitely that's why we have those, I would say, simple appliance instead of having something really complex. So okay, we've talked about robots in our houses. What's going on the professional side? So if you looked at the news since a few years, you may have already heard about totally automated warehouses, meaning that instead of having people going from that point to that other, then get back to the central point and move things around, we use more and more those little robots. As you can see, they are red. They can be from other colors. But interestingly, it doesn't look like at all a person, or it doesn't have any arms, any legs. It has little wheels, and it will move things along with the help of other systems to move the package and get the package on top of it. But definitely they are autonomous. They don't need people to get things done. And as you can see, they did not choose to get robots that looks like person. They went to something that is totally autonomous. It's really simple, wheels, a little plate on the top, and being able to move and understand the environment, the direct environment, to make things happen. Interestingly, it's a controlled environment, meaning that at some point, if someone shows up in the middle of everything, they will all stop. They just can't operate with someone that may move, and they don't understand what will be the next move of that operator or that person in the middle. While if you look at regular warehouse with person, definitely they can move, they can react, they can understand other people and make decisions. Sometimes they are bad and you may have an accident, but definitely they are able to understand or perceive their environment and change a bit, change their behavior depending on it. While those robots really need to be let alone, and if at some point something bad happens, then we stop everything, we get things done, things better again before being able to start them up. In the middle, there is those big arms in factories. Definitely something we can see since a long time ago in factories to move large parts, heavy parts, to solder them, to make a lot of different actions on them. But it's in a chain, meaning that we control everything. There is no operator moving around while the arm is moving itself. We have the space for person, we have the space for robots, and they act together to get cars done, but definitely not at the same time, at the same point exactly. They have to be separated. And last but not least, it's some sample examples, and definitely there are others. If you want to talk about other examples, or if you have questions about them, don't hesitate. But it's really simple example. Surgery. Surgery, what's interesting, instead of having a full autonomous system, you will have a surgeon that will work with this machine. The first thing you may think is, okay, it's really good because he may be in another hospital or even in another country, and being able to pilot this surgeon robot, I will call that. It's the case, definitely, and it's better because you may have some really good specialist that is not living near the patient that will be able to operate the person. But it's not only about that. That machine is able to finish the operation by itself, meaning it at some point, okay, you have the surgeon that will decide to cut that thing, to move that part, etc. It will do the main parts. But then when the surgery is finished, why you should close the wound or do things that you always need to do during the operation? Let the machine do, because it's really simple. It doesn't need a specific way to do that depending on the patient. It's really something that is able to do really good, really fast, with no help from the surgeon. That's really something that's interesting, meaning that the part you don't want to automate, it's still a surgeon that do that, and it's really important to keep it that way. But at the same time, for other mandatory processes and things to do during the surgery, definitely you can let the machine do it by itself, and it will do it really well. So what we can tell about all those examples, first thing, it's always a controlled environment. Definitely you don't want to have a foreign person running on the surgery, during the surgery on the same space. They are really, it's closed, and it's only person that are aware of that surgery and that able to act correctly that are in there. Same thing about the warehouse, same thing about the factory. So that's really the regular robots and machines that are autonomous, and we can see on many different examples. and that's why it's not easy, but at least it's something common. It's because of that controlled environment. And those specialized operators, people that are trained since years on those machines and able to work with them and be able to move around them without disturbing their function. Okay, so now let's see what may happen outside of those factories or hospitals, etc. First thing, the main difference when we talk about them, it's the uncontrolled environment. You can't control everything, such as for the exoskeleton. You don't want an operator with years of training on that. Why? Because if we're talking about years of training, if that operator at some point go somewhere else in another company, then you lose what he was trained for, and you can't you can't keep that way. You need someone that is able to work with that machine really fast. In this particular example, it's not someone that will be trained to use an exoskeleton. It's an exoskeleton that will help somebody. And it's the same. You don't want to have a few years or tens of years of training. You want to have it as easy as possible to use. So he will be able to use it to help him, because it's definitely a disease or he's not able to move completely, and he will need the exoskeleton to help him. Interestingly, you may think that it's an easy problem because, for example, you may have seen those robots that are able to move in really complex environments without the need of people. But actually, when you have this exoskeleton helping this person, it's really difficult to get correct balance. Really difficult, because it's moving. The weight of that person is not centered or is not really low. It's like you have most of the weight at the top of that person, around the chest. So it's really something that is bizarre and difficult for the machine to understand, compute, and accompany. So that's why also it's really difficult to get those exoskeleton work with persons. It's easier to get an exoskeleton alone, so meaning that it's a robot with legs and arms, but alone. Or if you have someone into it, then you want to make sure that this person is able to manage the balance itself. We have years of experience falling and getting up again and again during our childhoods, and that's why we are really efficient about it. It's not the case about those machines, and we still need to get there. And on the right, you have the autonomous car. So definitely something that is much simpler than something with arms and legs, etc. But really complex. Why? Because of its environment. You have other cars, you have bikes, you have people. They don't act the same way always. At some point, someone may be, okay, I will go to right. Oh no, I forgot. I need to go to the left. So you have to be able to understand that. Sometimes people will cross the road without waiting for that green light. Some other time you may have different weather, sunny. Okay, sometimes it will be fog. Some other time it will be night. Some other time. So the environment is always changing, and that's why it's really complex to get those cars. First thing is because they are really dangerous. If they go too fast on something, they may break those the other parts or the person. It's even worse, the person that may have a crash with that car. So you need to be really cautious, and that's why at Google and all other companies, we are still at early stage about those autonomous cars. But they are getting better and better on driving, and we can already see that they have less accidents than regular person when they are piloting those cars. Okay, so the difference between the other part, uncontrolled environments, people, weather, many different things. Users instead of trained operators. If you want to have an autonomous car, you don't want to have someone trained for a few years on it. You need someone that will buy that car or will use that car, such as the same way as he will use another car or a taxi. So really something to keep in mind. Okay, here is the cat again. So as you can hear, is really in good shape. And so uncontrolled environment, you may think that we can think of everything that could happen, but definitely it's not the case. I don't know if you can hear the engines, but definitely I don't think that someone at Google or any other place were thinking, okay, when we will have this drone running and being able to deliver a package to people, definitely we should think of a potential raven that could try to harm our drones. That's why it's really sensitive, the time between you have run on a simulation, then to work on an actual drone that will work but in a controlled environment, and then the last step, outside of your own controlled environment, being able to have a drone that will act correctly on it. And so you can, I don't know if you can hear it, but definitely the motors are trying to compensate what the Raven is doing to the drone. So yeah, nice. The package was delivered, as you can see, and no Raven has been harmed during the process. But it's not the only examples. There are a lot more. Here is another one. And same thing, the Raven sees or hears the drone and then try to attack it. So yeah, we at Google, so it's a company, a child company of Alphabet, the Google group, who were operating those drones in Australia, and they finished to provide that service, at least for a few months, mainly because of those attacks. They were not expected. And the main problem is not exactly the potential harm the Raven can do on the drones. It's mainly about, okay, what happens if the Raven, by accident or purposely, is able to take down that drone. It will fall down. If there is any person or anything that could be fragile, it can be worse than only, to have this package badly delivered, etc. So that's really something we have to always to think. It's whenever a robot is getting outside of that control environment, what we need to think of, get a lot of tests, and that's why also there are a lot of jobs open on that field, because it's not only about designing something and then getting it shipped whenever we need it. It's also test again, and making sure that is able to safely react to expected and sometimes unexpected events. As you can see, the engines are trying to compensate the bird, and I believe that was meant for wind. So good luck. We were really lucky here. We were able to compensate it and get things done as it was expected. But it's not always and you're not always sure to get this luck. Okay, so let's go to careers opportunities. I will go in a few obvious career paths, but others can be less expected, but as important as others. So the very first thing is maintenance, definitely. You need to get the mechanical parts revised a lot of time just to make sure that they are operating the way they should. Batteries, it's really something whenever it's undead, so something that is not connected to the main power, to the regular power socket, you need to think about batteries. What's their lifetime, how to operate, what if the battery is not as good as it was, and then change them. The configuration, we found everyone on those fields are taking a lot of time to get things correctly set and able to work during their lifetime, meaning that at some point they can be a bit more used, so not that efficient as before. They need to be calibrated again and again and again just to make sure that everything works as expected. Operators, definitely, a lot of them to program, so to tell the robot the first time or to program during the development part the machine, the robot, to get its mission done. And so for that, you may have something such as the surgery machine we've seen before. So a surgeon that will work with it, that will be trained for that, and that will operate for a few parts the machine and let the machine do other things. Optimize. So you don't put a robot on its environment or its uncontrolled environment, then don't look at it again until its end of life. More and more, you will check it, you will change it, you will modify it, you will make sure that it works better and completely in a safe manner, and yeah, revise the operation again and again. Trainers, so most of the time it's the maintenance person or the operators. After a few years, they get really good at their job and they need more person to be able to do that. So that's also a career path we see more and more, and we need them to get things to get things done and get people being able to use safely those robots. Electronics, obviously, high voltage, such as in cars, to get the motors correctly supplied, or low voltages to get any other kind of circuitry able to work correctly in a safe space, with safety and also reliability in mind. Because at some point, if you have things such as okay, rain or etc., what does happen to my robot? Can it continue to work or not? Then what should I do? Developers and engineers, so to create algorithm, to design parts, create the interfaces and make sure that everything works as expected and is able to fulfill the mission at the very first step of designing the products. And then fundamental research. And interestingly, there is, it's not only about having some robot specialist, is much more having person able to understand a problem. For example, someone after an accident is not able to move as expected. He needs an exoskeleton to help him. Okay, so what are the different challenges we need to tackle to get this exoskeleton able to help him as expected? And then you will see that there are a lot of different fields that will come. Health, definitely, interfaces with the person, being able to train him, etc. So there are a lot of fields to continue to explore to get those robots able to help person. So that's really something important. What I would like to add about that, how to start to work on a robotic field, because you don't want to pay for a full exoskeleton. or for a full robot, or for a few tens of $1,000 drone that is able to deliver a package, and then start to learn the career path with it. It's too expensive, and you're already choosing a specific path while you need to learn the basics of it. So the first example that comes in mind is study everything that can help to automate something, and definitely homes are a good target, mainly because everyone understands the potential benefits of having a smart home, such as I open the door, I would like to get those lights to turn on automatically, or any other kind of automatism, such as, okay, it's too cold today, start the radiators, or the opposite, get the AC turned on because it's too hot in the house. So many different really easy I'd say that use cases that will help you to get things down, and being able to transmit to your students the use cases, the challenges, and why it can be important to get things this kind of things to work. Then you can go with more complex use cases. What I will call more complex use cases. The home is kind of easy to automate, and even with a few tens of pounds, you are able to get things that a very simple thing that work. But then when you start to get on video games, for example, or to start to work on things such as that are more complex, such as recognize objects in a camera, you will see that there are a lot of different problematics you may encounter, such as, okay, the control or the uncontrolled environment, and also other very specific or very time sensitive things that happen. If I open my door and I want to turn the light to turn on, I can definitely wait for a few seconds, 1, 2, 3, no problem. At the opposite way, for video games, time is everything. So if, for example, an enemy enters the screen, you want to jump over it or do any other kind of action before it harms your player, your avatar. So definitely something that's important and interesting, and also you just need programs. So if people have a computer with open source softwares and emulators, game emulators, with all games, you can go even with a Pong, a very simple Pong. You are able to create a few use cases with, I would call that really early robots with no equipment at all. Then we can look at pre-built robots. What I will call pre-built. For example, there is Lego, who provides different kinds of robots, and that's definitely interesting because you can build the robot, understand the moving parts, the importance of the engines, to be able to transmit torque or speed or anything like that from one engine to the wheel or any other moving part. So that's really interesting to study. And at the same time, you have most of the time a program, an algorithm you can create with Scratch, really easy for person, or with advanced or regular languages such as C, Python, or any other program languages you can find. Then it's a few hundred of pounds to get something that robots that is already advanced and able to perform different tasks depending on inputs you will have. Then we can go to something that is much more, I will call that root, because it will need to get hands dirty. It's about embedded electronics. You have a lot of circuits a lot of samples and tutorials you can find on internet to help create an embedded circuits. For example, you can start something that will that will water a plant, getting a sensor on the dirt to know if the plant will need or not water, and then action a pump to get water to that particular plant. And you can think of many different really simple circuits, but that will need to understand exactly the use case, understand the different variable, the different sensors you will need, and then what kind of things you will have to activate to get that that function, that little autonomous system work. And then last but not least, real world challenges. You can design, build really simple or complex, depending on what you need, systems with, for example, a little arm. You can find programmable arms on internet, a webcam, same thing. It's really simple to find, and then being able to first I would say that to cartography an image from the webcam, and then tell to the arm to go to that particular part of the image. So being able to action the different engines, the different actuators, and other parts of that arm, to get, for example, to be able to sort things or being able to move parts. And interestingly, that's something that is in a controlled environment, but definitely that is sufficiently complex for students to understand exactly what's going on about robots, and how to go from something that is an idea, a project, to something that will work, that will do something that is useful. You can even have something that will, for example, sort waste and be able to get all the aluminum canettes. I don't know if it's the correct name, but the aluminum cans from to a specific waste, or even something that can be just a test, such as, okay, a camera, it looks for the waste bin, and then at some point, if someone tries to get some waste that is not meant for that particular bin, to get a warning or a message, please put it on the other bin because it's not where it should be. So a lot of potential challenges. It takes time, but it doesn't need a lot of money. But at the end, you may start to have some I would say that some students that would be able to build something in a startup, to build something in industries, or any other company that needs robots. So that will be all for that presentation. I don't know if there are any questions.
We'll come to Rachel in a second just to see if there's anything being submitted separately. But one question that I had: what do you, in your opinion, what do you think's sort of the next wave for robotics? What's the next exciting thing to come?
Well, it's more and more robots able to move, act in uncontrolled environment. That's really something that is difficult. You have limited power available. You have limited budgets. You don't want to pay a few tens of thousands euros for something that will do, for example, the cooking. Why? It's because if you start with that machine, then why you don't order from the restaurant? It's cheaper, and you have a lot of different things you can get from it. So definitely having more and more robots able to move, to act on uncontrolled environment, and with more and more complex tasks. I've talked a little bit about this surgery machine. You will see more and more surgery machine that will be autonomous, meaning that at some point they may be able to do some really easy operations such as, I don't have, sorry, in English examples, but definitely something that you will see more and more. And same thing about, for example, delivery. Instead of having a lot of person in motorcycle, etc., more and more having drones or little cars that are able to manage to deliver package themselves. Same thing about autonomous cars. So as you can see, it's getting all those robots that are working since years in warehouses, in factories, etc., outside of them and able to work to do things for us. Does it answer the question?
Yeah, no, absolutely. I was thinking when you mentioned about the surgery. I'm not qualified in healthcare, so I don't know if I can speak to what a simple surgery is. But I think the prospect of having an autonomous robotic surgeon maybe perform an appendectomy or something is exciting. I think I'm curious how far off we are in time from making that a reality, whether it's something that's happening in next year or next 10 years.
In that current moment, they already exist, and what they do is, I'm sorry, I have only the French word, but recoudre une plaie. So it's able to close the wound and do everything at the end of the operation without needing to have the surgeon to monitor or to do it himself. And it really does it fast and good. So it's a first step, but definitely robots are learning from person that are able to do it, because all the time the surgeon is moving the arms, moving the things that cuts, etc., on that person. It's not something that an information or a data that is lost. It's kept somewhere, and the different provider of those machines use this experience, this built-up experience from many different surgeons to get those robots more and more autonomous. And that's also something we can see in many other ways. For example, a car, it doesn't understand or it doesn't learn to drive a car by itself, by crashing it in one wall, then one other, oh, okay, that's good, that's my road. They will learn from actual drivers that will drive correctly and safely to the destination. And then the computer and the data scientist will perform lot of testing in simulation environment to make sure that this model of a smooth driving experience is able to react to other real world problems. So that's where the complexity comes. The same thing for a patient or surgery. If we were all made the same, definitely there will be more autonomous machines and less surgeon. No doubt of that. But we are all very different. During the operation, it's not only something that is completely planned. Sometimes the surgeon will make other decisions depending on what he finds during the operation. And same thing, the machine is not able to do that itself. We need the expertise of the surgeons. So that's also all these experience and all these important steps of having a human assisted with a machine is important, because we learn from it, from the machine. We learn from it with the help of all those data scientists and experts, and that's where at some point they will be able to perform more tasks autonomously.
Excellent. Excellent, thank you. So Rachel, is there any questions from the question box?
Yes, there is. Tony's posted a question and he's asking, do you think humans will ever have robot parts or organs in the future?
Interesting. Not only in the future, if you look at the last few years, there is a few person with a robot heart, so a pump. I will call that a pump, but it's definitely more complex than that. So it already exists. We can see also that, for example, for person with failing alors les reins. I'm sorry, I don't remember the name of in English of a rein, but definitely kidney. Okay, I got it. But definitely the main problem of those machines, first thing is they don't have the lifespan of a regular organ. So definitely difficult to keep them for tens of years working as expected. And the second thing is also size and battery, meaning that at some point they need to be found. They need a power supply, and they also since they are doing some complex tasks and they need to do it very carefully and really precisely. We need to have some extra parts that the human body does it by itself. I can't explain exactly the different complexity, for example, of a heart, but definitely that's something that's huge, because it doesn't send the blood, like it will first pump it, get it in the heart, and then send it to the organs and to the rest of the body, and it does it in a really precise way, and to have it working, it takes a lot more volume with a machine than what it takes with a regular heart that will grow with the human body. Like, just think of a baby against a full-grown person. It's definitely crazy to see that how the body is able to adapt, and all the organs are able to follow. And that's one of the big part we lack in robotics. At some point, we are able to build something, but it will work not for so many years, and also it will be able to do a really specific task at a really specific point of time of that body, but not to change with that body. So you can see more and more robotics part, and for example, persons with problems on a hand or an arm, etc., able to move a robotic arm, and it works with only the mind. So they don't need they don't always need to get some moving flesh. They are able to move it by what they think and our understanding of the brain signals. So really nice and really really fascinating. But at the same time, it's really complex, and you will see that the human body is able to do some extraordinary things that we do regularly with no problems, but that a machine is not able to do with the same precise way, and not able to adapt in so many different things that can happen to a regular person. So we will see them more and more. We already see them for specific handicaps, for specific persons with heart problems, kidneys problem, etc. But at the same time, every part, every human body parts that are changed, we can see that they are not that efficient after the change, and they need more maintenance. So don't buy this mechanical arm instead of your existing arm. Keep your existing arm for a long time again, and maybe in the future we will see those body parts such as in Star Wars, but definitely we are not here yet. It's only when you don't have other choice, not that bad, but not better than the human body.
Thank you, Alex. Fabulous answer.
Thank you.
There's no more questions coming in.
Wonderful. Okay, smashing. Thank you. I know we've got, or I think we've got David, our subject specialist online. So I'm just going to go to David and see if he's got any questions.
Yeah, I was just thinking of it from like a security perspective. I don't know what your thoughts are, Alex, on you know, what you think the biggest security challenges we've got with robotics. You know, and by that I mean, you know, thinking about where you was looking at the drones earlier, maybe like using them for surveillance or eavesdropping, or even being hacked into, that type of thing.
That's really an important part. You're completely right. Actually, the security can be also for those human parts. For example, the pacemaker. At some point, you need to be able to exchange some data with it to make sure that the patient between two visits to the médecin, to the doctor, that is definitely well and there is no problem. And the hackers already show that at some point they are able to do some bad things with those pacemakers and those other parts. Same thing happened with the drones, for example, but it's complex because at some point you need more security, definitely, on those devices to make sure that someone that will try to attack it is not able to do it efficiently. But at the same time, you need definitely some ways to get into the drone and being able to block it. Because, for example, if you're near an airport, definitely you need to be able, for example, to block the Wi-Fi signals without disturbing les avions, the flights. Sorry, I don't have the word. But definitely to avoid disturbing the airport systems and the flights, while being able to block those drones. So that's really interesting because it's the same thing as any other systems. For example, industrials, for example, internet, etc. You have some teams that try to strengthen and make sure that is able to work as expected, safely, and with less security loophole as possible. But at the same time, I don't know if we need security loopholes, but at some point we need to be able to remotely and in some cases being able to block it, because if we can't, then we may be losing the control of that system. And most of the time there is no big problem, but again, around an airport it can be really difficult. Around a power plant, same thing. So you have to keep in mind that a fully autonomous system, if it doesn't have any weakness, if you can't stop it, it can be problematic.
Yeah, thanks. And it was good to see when you'd mentioned before on that last slide about the using the Arduinos or Raspberry Pis. Do you think it's good experience for like tutors if they was setting up Arduinos with sensors and then setting up small class challenges based around that type of thing?
I didn't get your question. Sorry.
You'd mentioned on one of the slides about using Arduinos and
Raspberry Pis, etc. Yeah.
So would you recommend it's a good experience for tutors to use small challenges with groups of students working on building real life solutions using Arduino kits?
Yes. Actually, they are more used in industrial systems than what you may think. The only problems they can't help tackle are around high voltage, because you have a lot of potential interferences. I don't know if it makes sense, but a lot of interferences, and you can't have these systems that are not shielded against them around those big systems. But outside of that, they are really simple to use, and you will see that students will see them during the evaluation and the building parts. And at some point, they will design their own chips, their own circuits, depending on existing parts they can find on the regular suppliers, such as Texas Instruments and others. But during the prototyping, definitely they will use them. So no issues. Definitely a good way to go. Even more if you look at the resources on internet. because many people are doing something with them. Put the code, the programs, the algorithms they used on internet with pictures, with what they needed around that, how they supplied power to it, how they used it, the different motors that are compatible with those systems, and you will see that it will be really easy to get your course done. And for students, they will see those parts then during their career. So no troubles. That's the way to go.
Excellent, thank you.
You're welcome.
Wonderful. Well, I think that's all of our questions. So as always, thank you very much for your time, Alex. It's been a fantastic presentation. Really do appreciate it. And we'll be joining you shortly for machine learning, I think, coming up. As always, for anyone attending today, we're happy to share over the slides again. And if there's any follow-up questions that you'd like to put to any of the team or Alex, if you'd let us know, and we'll get those answered for you. But for now, just thank you very much for your time, and thank you for everyone for attending. We'll see you next time.
Thank you. Bye-bye.
Thank you. Bye-bye.